We're good to go. Julian, can you hear me okay?
Yes.
All right. Welcome, everybody. Hello, and thank you for joining us today. My name is Jeffrey Cuff. I'm Vice President of Product Management at Open Assessment Technologies. OAT is based in Luxembourg, and we have a large international footprint, but I'm based here in the United States. At OAT, our primary product is TAO, our digital assessment administration platform. TAO is unique in that it's available as an open source assessment solution, and that means you can download it and install it in your own environment with zero licensing costs, and it's supported by OAT and a global community of users that can contribute platform enhancements back to the community for everyone to benefit from. But that's enough about us. I attended the inaugural Beyond Multiple Choice conference way back, I think it was 2018 in Washington, D.C., and the idea of technology enhanced items and going beyond the notion of multiple choice items for mainstream assessments was just beginning to take hold of the industry. I've attended the conference multiple times since, and I've had the pleasure to present about work we were doing or work that we had done to contribute to more authentic and engaging assessment contact. As the impact of artificial intelligence increasingly influences not only assessment, but education in general, I think this notion of what comes beyond multiple choice is more relevant than ever. And with that, I'd like to introduce Julian Sabir. My pronunciation is not as elegant as Julian's is, but Julian has worked with OAT for over 6 years, primarily as a business systems analyst, helping to contribute to the TAO product roadmap and promote interoperability, a key component of our platform. He now splits his time between OAT and One EdTech. One EdTech, formerly IMS Global, is the leader in developing, certifying, and promoting open standards and resources intended to reduce complexity and accelerate innovation through common standards. They support QTI, LTI, and CASE, among others. Julian is focused on helping advance these standards and their adoption across the industry. And for that reason, I don't think there could be a more qualified resource to talk about how innovative item development and the application of those items to more effectively measure cross-curricular and high-level skills can be used in a world that increasingly depends on science and technology. In this presentation, From Prototype to Practice, Innovation in Math and Science Assessments in a Digital World, Julian will discuss how GeoGebra portable custom interactions, PCIs, can be used in practice from development to implementation at scale. I understand we'll have some time at the end of the presentation to take any questions, so if you can kindly include them in the chat window, we'll address them at the end. And with that, I'll turn it over to Julian.
Thank you, Jeff. Yeah, I'm sorry. Okay, I will share my screen. I wanted to go back to the basics, what beyond multiple choice means. And I've seen many presentations of many different aspects of assessment, and I think it was a good thing to have one session going back to actually talk about what is beyond multiple choices. I'm sorry. Maybe what I can say first is that we had different customers with different requirements, different needs, and this made us progress on including more and more ways to assess and not stay on the purely digitalization from paper, but just like translating what we have on paper into a browser. We can go way beyond that, and that's this journey I will present today. Couple of clients I can mention is, for example, the OECD PISA program, which is deployed in more than 80 countries, and which was quite a challenge to make proper, and that will be one aspect of this presentation. Another client I want to mention is the New York City and the New York State Education Department, with whom we are progressing on making their assessment move from paper to digital in different steps. One being transforming what we have today, paper, into a digital form of this, and then in the future to make it evolve to more diverse ways of assessing students' progress. So our agenda today would be a first look back in the beginning, then what the digital age brings up and how we can get more engagement from the students, and not only the students, and see which improvement directions we can have. If everything goes well, I will have a small demo for you and questions, and finally some key takeaways. So in the beginning, there was the pen and paper and the multiple choice question. And this is the origin of this conference. And I'm happy to go from this point and to see what it has as good points. It was easy to create, to productize, to grade. It's still prominent today. For example, the ACT tests are still 50 to 70% multiple choice questions. And it was, for decades, it was a very easy solution. And now we should see that as a legacy, because there are downsides also. It's not very efficient to evaluate critical thinking or problem-solving skills. This is very an important point, that just with monkey testing, you can see that achieving a grade could be done in an improper way. It's not accessible for everyone, especially when it's on paper. The digital version of multiple choice questions adds some possibilities, but that's not the panacea. And it's not diverse. It's only checking one question about among different ones, and that's not very creative, to be honest, and it doesn't really target everything you want to understand and learn from the student. And it's not very engaging. It's very terse. The digital age brings to us, as Jeffrey mentioned, TEIs, technology enhanced items. This is a way to go to have a better engagement, a better learning and knowledge sharing from students. And for this, we will have different aspects of it, various question types, interactive content, and personalized content. So about the question types, since I'm very involved in QTI, I will mention QTI a couple of times during this presentation. QTI has defined 17 or 18 different question types, different interactions. That's the way they are called there. So you find, of course, the choice interaction. That's, yeah, we need it, absolutely. But we have other things like ordering elements, associate elements, make match in matrices, fill in the gaps, or other things. And also more graphical interactions, where you can pinpoint some different locations on a map, or have a free click on point interactions. And this is also an example of a order interaction that looks a bit more engaging. And maybe that's not enough. So on top of these 17 interactions, QTI introduced the PCI, which is the portable custom interaction. This is a way to embed any web application with a reasonable size, which is composed of HTML, CSS, and JavaScript. So anything that you can develop on the web, theoretically. This allows for simulations. This allows for more task-oriented questions. And the goal of the role of QTI is to embed this into an assessment formalized with the QTI format. So the PCI itself works as an API between the web application and the QTI container by providing a set of functions that allows the application to interact with the surrounding test runner. And it allows also, since it's portable, it allows to have all the communication, all the data, all the scoring, be able to run in any delivery platform. Also, it's parameterizable, which means that, for example, for translations, you can have all the strings in PCIs as variables and then inject the proper language. About personalized content, this is something that connects to another aspect of the OneTech standards, that's LTI and personal needs and preferences. The idea here is to be able to provide some additions for some students, for example, in terms of accessibility, or if a student need different color scheme or additional time to take the test. So this is a way to address between the content, to have a specific content triggered by settings in a rostering tool. Also, we can have some test taker tools like a line reader that helps the student to focus while reading a test, or you can have an answer eliminator or a magnifier or different tools. And there is also all the question about accessibility. And I wanted to mention this tool, which allows you to figure out how people with certain disabilities can see the content. So it's not something to take for granted, but it helps to imagine how you can create your content in a more accessible way for everyone. So that's about personalized content. What we want to have today is more engagement from the students, because just multiple choices are not very fun, right? So what makes a question engaging? We need visual appeal. We need accessibility. We need challenge to solve, and we need good pedagogy. So about appealing, we need to identify the target audience. For example, during the PISA tests, we target 15 years old, but the 15 years old of 2025 are not the same as the 15 years old of 1995, right? There was a lot of changes in terms of UIs, in terms of usages. The 15 years old of today were born with mobile phones existing, so they have a different understanding of how to interact with UI. For example, I can mention the fact that most of them consider that everything is in application, and the idea of folder or file system is abstract. That's just one thing, and they are very focused and in terms of attention span on very short sequences. So that's one thing. Once we have identified the target audience, we need to check the text to media ratio. For example, this image on the right. This image on the right looks not very engaging. There is no image. There is only text, and that's a choice interaction. And actually, we will see it again later, because there is, as you can see, there is a scroll bar here, so there is something at the top. And we can use illustration to help understand, not only to make some better visual effect, but also to give some hints or some data to understand, to analyze. This is a good thing, but this also brings some inconvenience. For example, this very complicated image here is okay if it's just an illustration of something that is described on the side. But if it's the only thing we have to analyze, to answer the question, if it's an element to take into account, and it's not serving as illustration, then it has some drawbacks. The first one would be the accessibility. And the image I shared here it's not accessible. For example, it cannot be read directly by screen readers. So to tackle that, to address that, we would need alternative text. For example, this text is describing this image, and this was generated with a very simple prompt in an AI tool. So this is a place where AI should be leveraged because it's very down to the ground conception utilization, and this is AI for this is very efficient. Another way is to replace this image with something that's more accessible. Since this is a presentation, I cannot select the text, but actually everything but this part is text. So the image in here in this version is only comprising the color bars and the scale. Everything else is a text, so would be possible to be read by a screen reader. Why is it better? It's better for different aspects. First, because the image is simpler to read. Second, because we have better color contrast and color differences between the different bars we have here compared to this. And this, for people with some disabilities, is way easier to distinguish which color is which. And also, you can have, additionally to this, you can also have the alternative text. So this is a way better way to do that. Of course, it has a cost. It means that we need to take some time to create the image, to change it if this image, for example, was for a legacy test. And also, we need to spend time to position the different labels, the different elements of the full diagram. So it has a cost, but it's very, very beneficial, not only for people with disabilities, but for everyone. That's global lesson we learned from exploring accessibility. Another aspect of accessibility, making the things accessible, is internationalization, which means that, of course, when you want to understand and be able to reply, to answer a question, you need to understand what it is said, right? So for this, we have different aspects. We have the language and the localization. For example, in the PISA test, we had 80 countries, which is not 80 languages. Actually, it's not less, it's way more, because we have different languages for some countries, and we have different versions of the same language. Just take one example of Spain. Spain has 4 official languages. So we had 4 languages, 4 localizations for only the Spain as a country. Another important aspect is the text direction. Some scripts, for example, Arabic, Hebrew, or other languages, are written from right to left and not left to right. This is a very important aspect because it impacts a lot of people. So we are as Westerners, I would say, we are used to go for left to right as normal direction, and the wrong word in this sentence is normal, because internationalization is not only about the text direction, it's about everything around. Meaning, for here in this slide, I'm showing to you, I have a title on the left, I have bullet points on the left, and I have an illustration here, which is a secondary content. And when I move from one slide to another, I'm using my right key to go forward and my left key to go backwards, which is something unnatural for all the people having the habit of the text from right to left, and then the progression from right to left. And this is not an edge case. Looking at the number of people in the world, people using right to left scripts is more than 1 billion today. So that's clearly supporting right to left text is not an option. I think it's necessary, and it's a huge market to open. Another aspect is number formats. This is just a very simple example of a number written in the US using the separators for US. So we have the decimal separator, it's a dot in the US, and thousands separator, it's a comma in the US. In France, for example, the comma is used as a decimal separator, and for thousand separator, you have a space, which is very weird in some way, but it's actually the official way to write a number in France and many other countries. And another aspect which is which builds on the RTL question is the inclusion of left to right text within right to left text, which is what we call bidirectional text. So why this is important is, for example, for math formula, where you have this, it looks backwards if you are a Westerner, it looks the right way if you are Easterner, I would say. But you can see here, for example, the definition of pi is actually left to right inside a right to left text. So this is something most of the browsers support, but to just render it, to just display it is easy because the browser does the job. When you are creating an editor or allowing the test taker to enter some math formula, this goes way more complicated. Math formula are not the only places where we have a bidirectional text. We also have that in numbers. So in a run of text in a sentence, you can have a number spelled in left to right, or dates or references, for example, if you include a web link. So this is internationalization is a very a complex topic, but very interesting. Then another aspect is to make the things nice to solve. For example, we have a lot of laboratory-like PCIs that allows you to play, to have a more playful way of understanding the things and then answering the questions, where you can experiment. So you can find out things by changing some different parameters and see the things evolve differently. Gamification, of course, as I mentioned, playful is also a very important part. And here we can recognize the Scratch platform, which makes things look a bit more funny, a bit more easy to grasp for younger to learn how to code, how the idea of how to build an algorithm. And finally, we have this question of adaptive difficulty. If we have something that's too complex, the students will just disengage. Or if it's too easy, it's boring and you don't even think and you just click randomly, or you just go through the thing and it doesn't make you progress. So of course, this is a very important topic for us and leads us to this aspect of the zone of proximal development. So this is the correct way to make people progress when you have clearly defined what you suppose is known and what you suppose is not known at the time for the students. And using guidance, using encouragement, then targeting this proximal development zone, this is how you can improve engagement. Of course, this is something very important in formative assessment. And in summative, you would have more strict way, because you're not trying to make the student discover the things at the moment of a summative assessment. So this is more for formative, where you can iterate, you can have progressive lessons, you can have things that assess just what you have seen in the course just before. And of course, pedagogy should be related to academic standards. And so this can relate to case, for example, and curriculum, and the more you involve subject matter experts, the more your items will be exactly targeting what you want. Okay, let's look at the different improvement directions. I'm just looking at the time. Yeah, we could. So we have different directions that these progresses help. It's for the test takers, for the question authors, and for the graders and psychometricians. For the test takers, we can have partial scoring. What I mean by partial is it means that we don't have necessarily only a good response and a bad response. We can have something in the middle. And we can elicit the reasoning behind. This is very important. That's what we want to do now. And for this, we need to restore the state. For example, when the test taker, when the student goes back, because they change their mind, they want to see where they left the questions just before, right? So that's during the test session. And in formative context, also this helps in reviewing the session, in which you would display what the student answered, what could be the correct answer, and what would be the rationale behind the correct answer. So this is a way to take to give more explanation, to give more context to the test taker. For the authors, the partial scoring again allows to make the student more comfortable in not being fully up to speed with the concepts that are examined. It's always better to have a student to tell the student they almost got it, than just it's not 100% correct, so it's false. It can help to simplify item creations by parameterizing for template items. For example, I take a very down to ground example of you have an exercise with to assess arithmetics, and you have, let's say, a bakery selling bread and croissant or whatever. I'm French, I'm sorry. And you can specify the price of the bread, the price of the croissant, and then have in the exercise different clients coming in and buying different items and asking for the total sum they need to pay. A template item allows you to do that and then to feed in some different ranges of numbers. For example, you have different the different number of clients, the different products, but you can even think that different prices for each item, but you can even think that you can parameterize even the context. So instead of a bakery, you would have, I don't know, a grocery store, anything, or well, anything you can think of, and your template item would do the repetition that's needed for students to learn automatically, meaning that you can create your template, and then the system will create multiple exercises for the students to repeat until they understand. Another aspect is adaptive items, which is a way for an item to react. For example, it's not only feedback, but it's progressive questions adaptive to the answers. So this is something that we can do in adaptive testing, but you can also do that at the level of one item. And finally, you can have parameters for interrogation, as I mentioned before, by putting all the strings into parameters. For graders and psychometricians, this is my biggest slide. I'm sorry, it's a bit crowded, but we need to restore the state for the grading session also, which means that for the grader, the human grader, to be able to tell how the student performed, we need to show them exactly what the student answered. So that's basic. We need to have partial scoring, as in the previous slides. We can understand the reasoning behind, and for this we can adjust the granularity of the captured information, which means we can just retrieve the final state. For example, taking a single choice or anything else, you have what was the final response. But you can also log and report all the previous states. This way you can find out if the student changed his mind in the middle, or select something different before, or finally didn't answer because they were not sure. Another level is to log all the UI events. I mean in a certain in a reasonable manner, which means all the clicks and the keystrokes. This way you can find out the way the student, for example, for an essay, the way they wrote, if they wrote everything from top to bottom, or if they had to change the order. This can help a lot to find out the reasoning behind. And finally, but this getting huge, is to include all the mouse moves. And generally speaking, we try to discourage our clients to do that because it creates huge payloads. But that's possible. And it could be interesting, for example, for very graphical things like if you have a draw interaction when the student is asked to draw a technical drawing, for example, technical diagram. It could be an interesting data. Another aspect for psychometrics is that we can have the response processing at different stages. For example, if you create a PCI where the reasoning to decide if the response is correct or partially correct or incorrect. It's possible to do that inside the PCI directly. So this way, the creator of the PCI can also provide the logic for the grading. Another possibility is to do that in the item. QTI is extensible, so you can have custom operators. You can create very complex ways of understanding the response and transform it into a score. And also, of course, and that's the most relevant for psychometricians, is to gather all the data and then do psychometric analysis and or any other analysis you want. Okay, I will jump to a quick demo, which will involve, as Jeffrey mentioned, a GeoGebra system. So for those of you who don't know that, but I think probably you all know that, GeoGebra is a math and science engine with different capabilities. Sorry. That was developed in Austria. So that's the green thing here. This is a European effort, as you can see. We partnered with Wicked, which is a French company, to do the integration of the GeoGebra engine into a PCI, but maybe not the engine, but the possibility to integrate a GeoGebra project. And I will talk a bit more about GeoGebra just in a moment. We have OAT, which is located in Luxembourg. So that's this small thing here. So we did the QT integration, and we partnered also with our client, the Lithuania Ministry of Education, about the content creation. So I will not show this. I will try. Hopefully my demo will work. Oh, of course, I'm sorry for that. So I will go. Okay, I will first show you the authoring, but very briefly. So the question here is about, understanding friction. So that's a physics exercise. And probably I will show you the English version of that. So as I mentioned, GeoGebra is math and physics engine, but it's also a community where you can create your exercises and share them. And that's a very important aspect of community-driven work. So this is the original project, as they are called in GeoGebra, where you can check the friction of a material against weight, and you can set different parameters. You can change the weight of the weight, sorry, of the block. You can change the surface area in contact with the plan, and you can change the surface type. Sorry. And the experiment is about pulling and see at which force is necessary to actually make the block move, so to counter the friction of the surface. So we have a start and pause and reset button, and we have also the step-by-step buttons here. I'm mentioning all this because the item has been translated in Lithuanian, and I'm sorry, I'm not speaking Lithuanian. I don't know if some of you do. So you have here the weight. Here you have the surface in contact, and you have the type, the surface type here, and the start, pause, and reset button. So this is the authoring part, and I think we have a fixed width, so that this is why it goes behind the actual canvas. And so you can change different parameters. I won't show you all this now because it takes time. I will just show you a preview of how it behaves for real. So I will keep the default settings and just launch the simulation. So you can see at one moment, this is a simulation, right? At one moment, you can see that the block begins to move, right? So the thing you can do is to try to change different parameters. For example, the surface of contact, the weight, or the surface material, and try again. And you would see, as you've seen here, that the diagram is different, right? So that's the thing. And of course, and that's why I mentioned you would recognize that, that's the question I had with then the understanding of what you have experimented. So this is something that you can have for several questions afterwards, for example. So that's the thing. I won't be able to show you the actual logs for the different levels of reportings I mentioned here. But you can imagine that we can have the final state, all the different settings we changed for the weight, the surface of contact and all that. And also you can imagine you can have all the clicks and all that, or even the mouse moves. So this makes this exercise way more helping in understanding what the student did, how much they experimented, which different cases they experimented, and so that they came to an understanding of and were able to answer the different questions. So I will go forward to this, and well, I'll have a couple of takeaways after that, but I think we can go for questions if you have any.
I'm not seeing any in the box just yet, or in the dialogue there. Julian, let me ask you a question while we're waiting, and if anybody wants to tee up a question. A couple things. Can you talk? There are two things. One is the difference between, I know you're versed with QTI and the advancements that the QTI 3 standard has over the QTI 2 standard as it relates to PCIs. I mean, in my history, PCIs, earlier technologically enhanced items in some of the PCI interactions were very unique to the authors of that coded item, and sometimes they weren't as interoperable as perhaps some of the more simple items were. And it's my understanding that 3.0, QTI 3.0 has addressed some of that in addition to accessibility in general by incorporating capabilities that make that PCI a little more transferable or interoperable.
Yeah, this is right. What QTI 3 brings in the picture is a better management of the integration. So it's pretty technical, but it's well, we deal with JavaScript, and as soon as you have integration of one element into another, that's basically one page into another, you can have technical challenges, and this is something that QTI addresses. I'm sorry, because this is very technical, but it allows to make sure that your PCI will work in any QTI compliant system, which which was not necessarily the case in previous versions of QTI, because the things were more loose in the way they were incorporated. Now we have some things more strictly defined, and some fallback mechanisms that should be implemented so that all systems can play back, if I may say that, the PCI, but also apply some styling to it, apply some possibilities to pass it on some directives. For example, when you want to restore the state, to be able to show the correct solutions. So this is all, to be fair, this is all being finalized in the QTI work group at the moment, and the PCI spec will be published very soon, hopefully.
Excellent, excellent, thank you. We do have a question from the audience. It states, I'm wondering if it's possible for the reporting to be scaled, as an example, for a group of students.
Yes, totally. Here I only talked about one student and one exercise, but of course there is no limitation. I mean, well, the sky is the limit, I would say. The more the file system size is the limit, I would say, in the sense that you can have any aggregation rules for the results. So you can report anything you want, and the deeper you go, the more data you go for further analysis. So yeah, there is no real limit.
Excellent. And then another question Joanna asks, has it been applied to early year settings, especially in gamified forums?
Yeah, we had I don't know in which extent I can mention the clients. We had a client in the UK targeting audiences of primary schoolers. So that was 5 to 8 children. And so the UI was completely redefined. We had something way more colorful, but also we had a way simpler way to, for example, navigate between items. And multiple choice question, which is still the topic in this for this audience, was very more intuitive, in the sense that you had different pictures to tap, and when you tap, you had a visual enhancement of the selected one. So yeah, it's been implemented, and the thing is, you can have multiple ways to implement that. We have a UX team that is always investigating new ways of simplifying the things and make the technology out of the way of the students.
Yeah, I think that it's such an important consideration. I think, you know, some of the early technologically enhanced items, they were challenging to understand how to interact with them. And so to measure what you're trying to determine from the question has got to be weighed against, well, can I interact with an item in a meaningful way? And I think this is an important consideration when you get into some of these.
Yeah, and again, I think that the audience, understanding the audience is a really key thing, because even for the 5 to 8 years old today, they have grown up with tablets, with phones, so they have a different sense than we could have with different generations. Right? Absolutely,
it's almost intuitive at times with those folks.
Yeah.
Here's another question. Digital assessments can, of course, be forward-facing and enhancing what we can assess, but are we still able to test classic analytical approaches to mathematical problems, as an example, 10 lines of algebraic proof, without becoming burdensome in a timed exam?
Yeah, that's a very good question. That's a very good question. Thank you. I think we can go past we have different ways to tackle that. And I'm considering the math, for example. We have math equations editors now that simplify the way we write that. It's one way to go. Another way to go, which is something that we implemented for Norway, is to have a type of question when the student can write on paper and they then take a photo with the phone and upload it in the essay question. So and with many different ways to interact, it makes the technology help and also choosing the way you want to answer, and which is a very important aspect.
Absolutely. I think that's all we have. Oh, no, here's some more questions. I'm sorry. Early years like reception or preschool. I think that's maybe perhaps in context with another one. I'm not sure. Let me ask the next one here. How about cognitive load on students that need to learn how to interact with the inputting math formula? And that's a little bit of what we talked about, I think.
Yeah. So the more the system allows you to have a natural flow, a natural way to interact, is the better it is. And this is why we continue investigating in user experience and how we can take into account every new advance in today's technology to integrate that. For example, about the touch screen and things like that. Of course, we support different media, different ways to interact. Like, for example, when you associate things or when you order elements, to be able to do that just by taking the thing and putting in the right position, right? With your finger, not using a mouse or not using a pen or anything.
Yeah. Okay, and then the other question, is there an open source version of OAT grading platform? OAT does have, yeah, we have Tau Grader that is part of our commercial platform. I can't speak too specifically about it, but I can tell you that we are releasing a new version of our open source platform sometime next year, and we will have plans to release the grader version of that subsequently as well. So more to come there. Keep an eye on our website for that. And let me see, I think, oh, we have another one. A lucky guess or hunch that turns out to be the right, keeps moving on me, that turns out to be right shouldn't be rewarded as if it were knowledgeable. Does this mean grading should depend on how sure the student is about their answer? Certainty-based marking. This can help in critical thinking or help assess critical thinking.
Yeah, that's a very good question also. We have different ways to look at this. One is to have the actual full log of what the student did. So that's a way we can define if it was just a hesitation or if that was a direct direct choice. This is difficult to we are not in the student's head, of course, so there is also a margin of error. The other aspect is I'm sorry. The other aspect is if you want to make sure that the knowledge is acquired, then you can have cross questions. So this is something that you can enforce with having different ways of formulating the same question, for example. And in this domain, AI can help also.
Yeah, and I've also seen a test structure that asks for the response and then a subsequent answer, or a subsequent question that says, how sure are you of that response? And so you can actually gauge whether or not they are guessing or they're confident with that response as well, and use that into the psychometrics of that item.
Yeah, or provide a rationale. Yeah,
exactly. And then another one here: what stages of designing exams, items, deploying and evaluating assessments will be easier to do with AI?
I'm sorry, didn't.
The question is, what stages of designing exams and items, deploying and evaluating assessments will be easier to do with AI? I think they're all going to be impacted in a positive way. I think it'll be interesting to see how this technology unfolds over the next several years. Recently, we were talking about a 6-year roadmap for some of the innovations that we have on the TAO product, strategic product roadmap. And the notion of the impact that AI will have across the board is sometimes so overwhelming that it's difficult to determine what that roadmap might look like that far out, because the direction that some of these new technologies will take us, I think, is going to change the entire landscape for us. But it will certainly impact it, I think, in a positive direction, and we've got to use it in a way that I think is responsible and meaningful for the assessment.
Yeah.
Let me see if I have it. I think that is all the questions that have been posted. If I missed anything, by all means, folks, just let me know. And other than that, if you guys have any specific questions later that come to mind, you can always reach out to me at jeffrey.cuff@taotesting.com. And I think that we are all set. We're running down to the last couple minutes. So I want to thank, there's another question there. But neurodiverse students not being tested in their native language may react differently in the way they engage with the items or tests. Would confidence answering here be misled? It's a good question. I don't know if you have a position on that, Julian, or perhaps more for psychometric response.
Yes, probably, yes. And thank you for the question. It's, yeah, it's maybe difficult to answer in 2 minutes.
Yeah.
Sorry for... I would have 2 takeaways for you. I don't know, maybe I can just share that.
Sure, absolutely.
This one, and sorry for the image. I tried AI for doing this. It was quite... I have making of, if you interested into that. That was quite a story. I think what we learned basically here is that the knowledge leads to curiosity. Curiosity leads to challenge, and challenge brings the students to make an effort to solve if we have a correct zone of proximal development. An effort, when you success, brings pressure, which brings engagement and which allows knowledge. So it's an infinite cycle, and I think it's always positive to go with more and more engagement and more progress. And the second takeaway, it looks very weird, but I will explain what it is. I talked about GeoGebra, and I talked about 15 years old. So my daughter is 15 years old, and she did receive that one day on her phone, and she did what I'm just doing here. She opened GeoGebra Classic and put that here. And to me, it summarized the way the younger generation take all this. And you will see why. I was just amazed by that.
That's wonderful.
Thank you.
All right, we are at time. I'd like to thank everybody for making the time in your busy schedule to attend this particular presentation, and a huge advocate of the other presentations that are out there. I think it's a tremendously valuable conference, and so look forward to hopefully running into some of you folks online in some of the other sessions. All right, thank you, Julian, appreciate it.
Thank you. Thank you.
We'll talk to you folks soon. Take care.
Bye.